previously, we installed the blade back on the TD25G, and the final step in doing that was hooking up the tilt cylinder. We didn't have a lot of history on this. I got that with the Maryland tractor, and it turned out to leak pretty bad. So we set off to rebuild this cylinder, and that's where this video picks back up.
That way we can tear this cylinder apart. You can't buy a kit for this one now. So I'm gonna have to measure it and order the parts individually. So I've rigged up some sockets, some bars from the press, and this is how we have to try to push that gland down. This works the same way as those lift cylinders did when we did them, if you remember that. The problem with these cylinders is that they're kind of going up, and so the rainwater goes down into this gland, unlike the lift cylinders, so they'll get stuck. And if you remember back last year, we did this at TD15, we had the backhoe pounding on it. So I'm gonna just go right to that tactic. Hopefully we don't have to beat on it. Let's see how this works. I moved my pickup out of the line of fire. Great success! We still got to get those locking rings out of there. I was just trying to get a little more clearance. Finally. So it seems like the last guy filled it full of RTV, which shouldn't be there. But hey, maybe that kept that gland from rusting on us. Alrighty. See if we can pull that whole piston assembly out of there now. Boy, that is a big ram. Curtis! Hey Curtis, I just went ahead and pulled this hydraulic cylinder out of our TD25 and it needs a fair bit of work. Do you think you could help us out with that? Sam from Scrappy Industries, good to meet you. I'm glad you brought your cylinder down here for us to work on. Oh, that shouldn't be any big deal. I've seen stuff way worse than this. Well, yeah, I tried finding a packing kit for it, but everyone says it's no longer available. I tried every outlet I had available to me where I've bought the hoist cylinders for the TD25 and the TD15 in the past, and everyone just says this tilt cylinder is no longer available. Nope, we'll get it fixed up for you, yep. That's no problem at all. Yeah, we'll get it in the lathe here. We can probably get it turned around for you today. Yep, we're gonna get right to it. They don't show you this in the manual. So we just so happen to have this wrench burned out from something on the 215, I think. I don't know if that's the bucket cylinder on the 215 maybe? Because the big one I think was the stick. But yeah, this is about the best we have. I think it's going.
It looked like it did the first hit, and I think everything was just...
Is it all staying tight over there? She is going. That custom tooling. Man, if somebody would at least run a grinder around this thing.
I'm kind of impressed.
Why?
Because The size of that nut, I did not think it was gonna happen.
Yeah, it must not have been torqued. Although, I seem to get some pretty good foot-pounds.
Yep. Rehook, or you want to try the wrench?
Hold on. I want a Snapchat.
We can't send a Snapchat without somebody hitting it.
All right.
Here.
This is scrapping hydraulic. Luberdube. I think that the pipe wrench, you think it has a prayer yet or not? No. Oh, you got her now. You like back off of it entirely. Ooh. It's still not that easy. I wonder if somebody Loctited it.
It looks a little green. Like, is it a nylock?
I thought it was a nylock, the green part.
Yeah.
Oh yeah, we're there now. Well, that took some serious horsepower there, Big John.
That it did. I'm glad there's only one of these on this dozer.
Yeah. Oh yeah, there's some heat in that nut. Piston off. Put that anywhere. Alright, and the whole reason we did this was to get to this gland fella here. This U-cup seal down here was our main leaker. That's just the dirt seal. She looks pretty good. See if we can get them all out of there and measured up. Just give a little tappy. Alright, that's our dirt seal, dust seal. And then we have, I think this is the actual seal, and then that's a wear ring. Seems odd that there's nothing though. I think nothing would hold the pressure in place. I think there's no groove of metal for it. Unless that's supposed to be more of a seal. I guess that is like a rubber band. Either way though, what's supposed to hold it there? Or is this metal that got blown out? Ooh, I wonder if it froze. Yeah, I think that's steel. That's not good. Yeah. That's exactly what we have. Well, we're going to be doing some sort of repair on that. Yeah, that's just a loaded U-cup seal. And that used to be all one piece. And that's all metal. Huh. Well, how about them apples? So you can see where the seal goes, and it's supposed to have that nice ledge there to hold it in place. And I think water got in there and froze, and it kind of died. So now we need to fix that. And I've kind of come up with a way here of making our TIG torch tiny. And then I have some nickel rod I'm hoping will work, because this is some sort of like ductile or cast material. You can see where it's broken out here. It's not just regular steel. So I'm hoping that'll work well enough for us to build this all back up and machine that groove out. It doesn't really need to be like perfectly oil tight from what I can tell, because the seal should be sealing back here on this groove. It's more just to hold the seal from pushing out from the pressure. Let's see if we can make it happen. Try to give this a little clean up first. I don't know how much oil's impregnated in there, or that's really gonna matter anyway. All right, there's our little miniature TIG torch. I think we can reach her through pretty well like that. We can see what we're doing. And we'll just work it up around here and dab the rod in. This is the rod we're gonna be running. NI99 in the 332nd variety. I've used this on cast iron before with pretty good success. Let's see what happens. This stuff is not real happy. So I think that will work. You just have to keep the heat down pretty low. I also feel like it could just flake off of there like nothing. Well, I can tell you I'm really not happy with how this is going, but we show her all here. I'm just really having a hard time getting this to fuse to whatever this thing is. And obviously we're gonna put this in the lathe and clean this up. But I don't know how much is gonna clean up, and I don't know how well it's bonded. It may just chunk out of there. We'll get in the lathe and see how it cleans up. We're gonna swap the lathe over to the big forward jaw hanging over there for this job so that we can grab it and move it around, get it all centered up properly. This is a long nose, or a long taper spindle, this is called on this lathe. And sometimes I just cheat and let the machine do it, but you don't need to tighten that too much, and it'll bump it off like so. Actually a really nice style spindle to change. I'm just gonna give everything a real good clean in here. You don't want any dirt or chips or anything, of course, on that spindle nose. Inside our taper here. Okay. And this guy. I'm gonna swing him right over there. And this nut on the back here. So these aren't a super common. I think this is an L1 taper. A lot of lathes in this era use the D16, like a cam lock, set of 6 cam locks. And what I've seen, we had an old Monarch at Penn State. It was an old Navy gearhead machine about this size, and it had the D16 on it. And there was nothing wrong with it. It certainly wasn't as fast as this machine is to change over. And somebody had built this little rack on the back for the chucks. It was already there when I bought this lathe, and it just works really well. As you can see, you can put a chuck on like this big guy here and not break your back. Put it like in a low gear there, and then you take your spanner wrench and just tighten her up. Good enough. And that's all there is to it. So on the back we have this nubbins. I'm going to try to hold on to that. So the forward jaw, of course, the chuck jaws are independent of each other. It's all on you to center it all up. So to start with, I just kind of eyeball off of these circles, and that gets you close enough to then come in with your dial indicator and really kind of figure out where you are in the world. So you can see on just kind of, you know, we haven't checked anything yet, but we're not terrible, but we're not great yet. We got to fix her up. So the way you actually dial this in is you have to put a dial indicator on it and, well, dial it in. So that's our high spot, so we need to tighten this guy. You can see it bring it down. It's our lower spot. We're probably going to need to back off of this side a little. It's just hitting it there. And that's how we work her into place to be where we need it to be. And let's see what we can mess up here. All right, so we bored that mostly through to size. And now what I'm doing is I'm set up on the bottom of that counter bore where the dust seal goes. I'm just gonna bring the carriage stop up because we obviously can't be there where my terrible weld is. So we'll tighten that up. Now, bump back out of the way here. We can keep on spinning her. So a lot of that did clean out. Now when we cut the front off, I think a lot more will clean out. And then we'll have to go in there with the boring bar and work kind of backwards and clean that groove out. And then maybe like another little bit of welding and it'll be good enough for who it's for. I'm doing all this at 112 RPM, in case you're curious. Seems like it's working okay. The good news is it's all stayed attached. I was kind of worried it would just chunk out of there. But some of these defects, like here, I don't know. It's not great. Oops.
Shake hands with danger.
All right, we got everything set up here. We got this just high-speed tool steel set up in this kind of makeshift boring bar to be able to reach in and cut the inside of that groove. All right, so I'm up against the carriage stop. And this should be our kind of last shoulder pass. So this carriage stop you can use, you could take it off and put it on either side of the carriage. So I put it over here so we could bump up against it. I just kind of set the tool off of a good side of that groove, and then, you know, once you're in there working, you can just trust what you already set up back up to it. And now you can see how much more welding we have to do. I didn't catch earlier how bad this side is as well. Like it's almost like it was eroded away. I don't understand. I don't love what we're doing here. I just think this job could be better, and maybe this side being that bad is, it's either the nail in the coffin of doing this at all versus just bore it out, or we resort to like the JB weld tactic. I don't like how this rod doesn't really bond to the base metal well, but the fact that it's still there shows that it adhered well enough, I guess. I don't know. I'm not in love. Take a look at that far side. It's kind of like somebody already was in there trying to repair this thing once. Decisions. I don't know that just making this whole thing from scratch isn't kind of the best decision. It wouldn't be that hard to do. I feel like what we're doing here is really not good. All right, so spent a little more time thinking about this, and what we're gonna do is just cut one big counter bore. I'm thinking we'll go to 5 inches. That's where this mark is from that external plate that bolts on here. If we cut a 5-inch counter bore into the inside of that lip, that'll basically be our new backing for the seal. So we won't need to seal the outside of that because the U-cup seal is already gonna seal that in here for us. We'll just put that in and we'll bolt it. I'm thinking we'll put 6 flathead, either Allen or Torx screws into that. And then we'll cut this counter bore here for our dust seal. So we're just gonna eliminate all this trash, and it's just gonna be like one simple part to make, and then we'll just have to drill and tap this piece to bolt that in there. So let's get going. Let's knock all this crap out of there and kind of rebuild, replace here. So because we need to cut 3/4 of an inch in, I'm just gonna bump that boring bar up there. And then this is a 3/4 inch square tool. So we're just gonna put that right there and then tighten that guy up. And you can fine tune that with the micrometer stop here, but that'll get us like a real good start anyhow. Alrighty, we're all set up now. Let's get started. pretty close to that 5-inch mark right now. Need to take a good measurement on it. All right, so we're just gonna run the 6-inch snap gauge here. All right, we're 5.044. I don't know if you guys noticed while I was turning, I sure did. See how this is so wrecked here? I don't know what happened to this thing. But I'm gonna go in and try to clean this face up a little bit here as well. It's like water was like between the rod and the gland here. It's weird. We may need to just move that seal in and we'll just take this whole depth back. Alrighty guys, that takes care of the machine work on this, other than drilling and tapping the bolt holes for our new piece. This is our brand new seal. So we put it in like this. So now our backup plate is just gonna hold that seal because the oil pressure will be pushing that seal back. So once we make this donut piece, it'll bolt in there next and it'll come to this same diameter. Maybe just make it a skosh bigger. But its main purpose is just to hold that seal in, and then we'll have a counter bore on this side to hold that dust seal. So that's all there is to it.
So we got our piece of steel in here to be our repair piece on this gland. And I highly recommend reaching out to your local steel yard when you need things like this, because this is 1 inch thick, like 5 1/4 OD. I just drew it up, gave them a DXF of 2 circles, but $5 is all they charge me. So if you're like me and you don't have your own burn table, your local steel supplier seems to be very reasonable on doing the burning for you, and then you don't need to stock a 4x8 sheet or whatever of 1 inch thick steel. Now, I ordered it Monday, got it Friday, so there's that delay. That's of course the nice thing about having your own, but it's pretty hard to justify buying one when it's that cheap and you don't have to stock all the different materials. So, I don't know, just a heads up to you guys if you don't have a burn table. With all that being said, I was just looking here how we're gonna hold this. I think I'll just grab the inside, open this chuck up, and we can turn the outside nice and true. And then we'll hold it by the outside, turn the inside, and we'll just kind of touch off on these faces here. All the internet Nazis will be yelling at me if I leave the chuck wrench in there. I bought it off a guy on Craigslist years ago, and it was originally a US Steel lathe, so I don't know, kind of cool. It was like a local Pittsburgh mill lathe in the tool room or repair room or whatever. So the only thing to really pay attention to on these burned out parts is like here, and they did hit it with a grinder. That's like their start and stop, and their start and stop on the inside. So as long as we don't put that where a jaw is, we should be okay. Trying to get that started. One thing kind of neat on this lathe is they actually integrated basically your surface feed calculation to the lathe itself. So if we come down here and say 5 inch, and we're running carbide, so we're gonna run, you know, somewhere in like 300 inches a minute. You could probably go faster, but anywhere in this kind of vector here. And it tells you up 242, 300 RPM. So then you come up here, say we wanna go, we'll run it at 242, I guess. And this tells you where you put your gear shifts to achieve that. And now we're good to go. Now we fire it up, and we'll get to machining. Not breaking chips well at all. Just cleaning up this outside face now. All right, now we'll flip it and face the other side. right. Let's give her a whirl. Look at that. Perfect. So now we're gonna have to run to work and use the mill to drill and counterbore this and drill and tap the gland. Otherwise though, that's just what I wanted. It's not, there's really like no slop in it. And then this is the old dirt seal, but we'll have to cut a counterbore and install that in there as well. And then she'll be ready to go back together. Just kind of laying out my plan. So this is 3.5 inch on the dust seal. Please 3/8 socket head cap screws. That's how big the head is. I think that'll work out nice. Alrighty, I just drew this up quick. Our donut here and our 6 bolt holes. And what we're doing is we're countersinking these pretty deep because these 7/8 long 3/8 socket head cap screws are what I have. So we set them down in, so we only have about 3/8 left, so we'll have a 1/2 inch into the gland. I think that'll work out well. So we spot drill, counterbore, and then chamfer the top. And then I just programmed the gland side right off of the same part, because all we're gonna do with it is spot drill, and tap. And that should all work out for us. That'll put the bolt holes right on top of each other with this and the gland. Let's go fire up the mill and get to her. We're gonna probe for the center of this boss. And because of course we didn't machine the inside, we're doing it off the outside. Now we're all centered up on the part. I'm gonna give this just a little check with the indicator. Here we are off a little bit. All right, we're within like a thou there now. So we can just come over to our offsets page. We're on G54. And let's do set X0, set Y. We didn't move Y, so it's still the same. And we still need to touch off our Z, which will just be anywhere on this top of the part. Everything's set up now. We can load our program and get to drilling. We got our program loaded on there now. Of course, this is basically just XY coordinates for everything. It's gonna start with the drill, the spot drill that is. This locates the holes more accurately. For this guy. Should have put some pecking on there. We are not breaking the chips. Now we're gonna go in and cut the counterbore. And it's just walking its way down that outside diameter. In a circle. Take a peek at that portion. All right, so let's try this out. That's what she'll look like. Cool. Now I'm just going to come in and deburr the back side of these with the old debooger tool. And so you can see what we have here with our socket head cap screw. That'll give us our 1/2 inch of engagement into the gland. Yeah, I think that'll work nice. All right, let's get the gland in there and drill and tap it next. Find center on this bore now. Alright, it was a couple thou, just the same on X, so need to recalibrate that probe. Typically it doesn't really matter, but I'm trying to be fairly accurate on this job. Now we're drilling with a 5/16 drill to tap for that 3/8 to 16 down in the gland. The part that always makes me nervous, tapping. Please don't break a tap. Once you start a rigid tap, there's no stopping, because the control's following the spindle encoder with the Z servo. Alright, off and running. Whoa. Didn't break the tap. Great success. Well, we're still set up here. Let's do a quick little sanity check. There it is. All the bolt holes look to be lining up. I think she's going to do the trick for us. Now all we have is to go back home, go in the lathe, bore this out, and cut that counter bore. And she's ready for reassembly. Well, boys, you ready to go home? Grab some dinner? Parts all ready to roll. We'll do that little bit of lathe work maybe after dinner, and she'll be done. Sweet! My voice is almost back up to sweet levels. I feel like I'm gonna catch some flack for this, but what I'm gonna do here on this, final assembly, this thing is sort of a permanent kind of install in my mind. I'm gonna put RTV on the bottom and kind of let it run up along the edges. And I'm gonna do that because as this thing sits out in the weather, I don't want water getting down in this little groove and rusting. Another thought I had was drilling and tapping some future jack bolt holes if you wanted to take this thing out. I don't know. Then they'll fill up with water, give it another place to get in. I'm thinking you could always take a brass drift coming from the back and knock this out if you absolutely had to. Now the other side of me is we're sort of band-aiding this gland back together with this insert. If something else goes terribly wrong with this gland, we're probably gonna be making a new one. So as far as that goes, I'm just gonna put the RTV to it. I'm gonna bolt that in. I guess we'll put a little bit of Loctite on these. That'll keep them from rusting and ultimately backing out. Really, probably doesn't need a whole lot here. Just trying to give this edge a little bit. And she's home. Mighty 4 jaws going back on. Alrighty. Haven't seen you in a while, girl. So verifying that we're tight up against the jaws here, everything looks to be good. And got her within about 0.02 of an inch total run out, which I think that's honestly about as good as we're gonna get. It's kind of like what we're running on in there isn't super round. It might have worn in one spot, like kind of against the rod or something, but all in all, I think we're in good shape. And the nice thing about this is that's kind of like a one-shot run out because this is now permanently bolted in there. So we don't have like the air of our concentricity here plus the air. When this bolts in, it's kind of like only the one air. So I think this is still better. Let's get to boring. So I'm kind of curious what they bored this to where the rod goes through. Essentially how much clearance on that 3-inch rod did they leave? Oh wow, it's only 3/1000ths extra. We might give a little more than that. Maybe we'll go 5/1000ths to make up for our concentricity error. I'm going to speed this up a little bit because we're on a smaller diameter. I'm going to run 431 RPM. Trying to be kind of aggressive and get underneath that hard stuff from where it was cut all in one go. We're going to touch off right on that face, and then we can use our micrometer stop here, and we can just dial this 1/4 inch that we need. We'll just set this thing out here somewhere, and then we can wind the micrometer stop back a 1/4 inch, and that'll set that counterbore depth for us to back up into. It's kind of all the old school ways since we don't have a digital readout here. This is, you know, how it was done back in the day. .3 is about right. This will take us out to 3.4. Whew. We've got to get this chip breaking sorted out with some tooling here before we get hurt. See if we could just reach in and debooger that edge. Otherwise, we're going to have to change back to our other boring bar. Before we get her pulled out, you can see what we have going on. Chamfered all that. Got our counterbore for the dust seal. We cut that to 5/1000ths clearance on the rod. I don't know how this is going to work with steel wearing on it versus this ductile. I think we'd rather this touches. That's why I went a little bigger here. It'll ride. We'll get these chips cleaned out and she's ready for assembly. Before we pull this out of the lathe, I'm going to check this out. Seems like we have a nice fit there on the rod. Now I just need to give her kind of a final cleaning. Gonna hit it with the air gun and blast any of these chips out of there. I ordered some cork so we can jam cork into all these. Trim that off nice. I'm just trying to keep the water out of there is what I'm concerned about. I think I might even pack grease down in there first and shove the corks in I just don't want water to get down in there, freeze, and cause damage like we had earlier. We're happy with that. Our U-cup seal goes this way, holding the oil in the cylinder. Alrighty. That's our main oil seal in place. This guy, I'm going to put a little bit of Loctite on him. Don't want it to pop out of there. That's kind of our final result. We got the main oil seal down there, our dust seal up here. So with that, we have this is our backup seal, which is this guy behind the O-ring. Looks like about the same. And I also got a new O-ring here as well. 2 new O-rings really. Seems like the one to me. Put that O-ring on there. This is what seals the gland to the barrel. So then behind that, we have this backup ring. You can see it's kind of got like a concave side there to face the O-ring. Give that a little lube. Scrap. And now, without further ado, our gland is all resealed, rebuilt. We can go ahead and put this whole rod assembly back together now, though. All right, we don't want to forget some crucial components. That guy goes on before the rod. I'm going to clean the rod up pretty well. I'm going to wire wheel the Loctite out of this as well, so we hopefully don't fight the nut on so much. Well, you'd be mad if you forgot that. Don't forget that. Gland goes on next. Yeah, it does. Come on. I feel good about our U-cup seal. Might be using the press to get that in there. You say cart ramrod? Man. Hey! And now it's on there, it's fine. You better not leak. Well, that took a little more effort than I expected. Seems good now that it's on there, though. Not too much resistance or anything, so. I'm gonna clean this up, clean this shoulder up, so we can put the piston on. All right, now we'll slide the piston on there. We have our whoosher. And then of course, our big old nut. I think I'm gonna not put Loctite on this and just trust the fact that it's an eye lock. A lot easier than when we took it off, that's for sure. Okay. And that's the proper torque in the book. So I tried to buy a new Teflon seal for this thing, but being that it's a 9-inch diameter, I can't find it anywhere. Like any of the kind of like the will call parts places, like where I got the backup ring and the 3-inch rod seals and all that. No one has a 9-inch diameter Teflon ring and expander that I could find. This one doesn't look to be in too bad a shape. Even if it does leak a little, that's just the tilt. You're constantly on the tilt anyway on a dozer. As long as it's not gushing out the rod the way it was, which I'm pretty sure will be okay now. It's ready to go back on the tractor now. The perfect holder. All right, we need to pull the bucket off here and kind of check out what this thing looks like on the inside. All right. Actually looking really good and clean. I'm gonna just kind of wipe out what I can and we'll put it together. So I lubed everything inside the bore with just this oil from the bottom. Once I get this hanging, I'll do some more of it here, but the only thing that's new are these O-ring and backup ring there on the gland. We didn't take off the piston ring, because if you remember, we couldn't get a new one in this 9-inch diameter. So be careful if you're taking apart your TD25 tilt cylinder. You may or may not be able to get all the parts. This guy was slipping at the end, just trying to keep the water out. I'm going to change up our rigging a little bit and just grab it by the eye. Okay. Put a little more oil on it before we get too far in there. I just want to make sure that we have a thorough amount of luberdube on all these surfaces as we go down in there. Don't think that there's anything to forget at this stage of the game. Once we're down in there, we'll stick the lock rings in that hold against this, and then that big O-ring on top of that. I'm gonna try to spin that so we're lined up. I think we can just keep on setting her. There it is. Piston's back in. Pull her this way. All right. That should be all we need from the 170. Yeah, that gland should just go right in there now. Yep. There she is. I guess the only problem is we don't want the rod to go super far down just so we can get our hands into those lock rings. We do, however, want to get the gland down in there. Where you been, cuz? Just give it a little tappy.
Something happened.
I think it did go some. That might be enough. Let's see what you got. Nope. Need more of it. Now we're going.
Yeah.
Think that's enough?
I think it might have bottomed out. Nope.
A little bit more.
Sounded pretty solid, didn't it?
Yeah, I think that's enough. We're trying to just hit that gland down far enough that that lock ring has to go back in. Yeah, I think it's good. Oh, we might need like another hit. No, I guess it's in there. Because that'll come up and clear it.
Yeah, it's lower than the groove at the top. Right there.
I think.
There she goes.
Okay. So there's that O-ring is in the bed of my truck. Yep. Kind of trying to seal the water out. I feel like
Where's it supposed to be?
Well, I don't know that it's even intended for this. It's an extra one that I used on the gland. Yeah, I don't know that's gonna work because it's gonna be too big a diameter anyway to fit in there. I guess we'll just hook the 170 back on now and just pull it up by the rod. I don't know if we fill it with RTV or just straight grease in that crack and just try to keep the water out of it. I don't know, the grease would really be the worst for it. It would last quite a while back in behind this plate. Yeah, you're probably not wrong. You need like stick grease, something really thick. Tar. I have this can of gasket maker. I'm gonna attempt to fill up as much as we can down in here like a cake. Icing on the cake, see? I just don't want water hanging out down inside of that gland and rust it to the barrel. I'm just gonna at least try to make like a pass around there and try to seal it up. You know, I think this may be like an entire mess, but we're doing what we can to try to keep the water out of her. It's gonna be just spewing out of here. I think this design is much more suited for blade cylinders pointed down to the ground where water intrusion is not an issue. But we'll make it work. Redesign for you, IH. These are the bolts, and all they do is hold that gland up into those locks that are actually doing the work. We might as well hook our hoses up here while it's easy. And we're just kind of going by length. Now these hoses 100% need to be replaced, but we're going to put them on there for the time being. The problem is that somebody replaced them on this tractor and they ran from here all the way back to the valve spool. From what I can tell, there should be a brake right there at the grill. Well, I guess it'd be wise to test it out right now before we finish hooking everything up. It's just too easy. Well, let's try her out. Pressure on this side right now. I've seen it be okay. Woo! It works! Your hand, Coach. The problem is there's no taper on that side of the pin. If we drove it from this side, it has a taper. Yeah. Little bit, Jimmy. Told you, K. Dodge. All that for that. Kind of curious how good the cylinders and everything want to hold us here, so that's why I left it a little bit above the ground. Well, I didn't move the camera, so hopefully we can see how far the blade sank. I don't think much. I think maybe like an inch or so, but anyway, that pretty well completes this task. I'm gonna move this thing out of the way here. The only thing we really have to push right now is a pile of snow, so maybe we'll see how I push a pile of snow. And that's the best snowplow ever. I don't know about not destroying things, but the sound and fun factor is definitely there. Well, thank you guys very much for watching. I'm Sam with Scrappy Industries. We'll catch you on the next one.